Hi everyone, let's have a look at today's maths. So the walk today is we are learning to find equivalent fractions, and the date is the 25th of the 2nd, 2021. So if you're working on paper, please do write your date and WALT in your book as you would in school. And if you are working on paper, you will need the following. You will need something to write with, preferably a pencil, but a pen is absolutely fine. An exercise book or piece of paper, a rubber and a ruler if you have one at hand, or of course you can complete it directly onto the sheet via Dojo. So we're going to go straight on to our starter today. So work out the following divisions using your times table knowledge. So there's no need to use bus stop for this. We're just counting out how many multiples within each number. So if you know your times tables, it helps you to divide as well. Most of the time you work out division answers through multiplication facts as opposed to physically having to divide. Alright, so you can see there's A, B or C, so you pick the best or the most appropriate challenge for you. Think about what you would usually do in school. If you would usually do C, go for C. If you would usually go for A or B, go for that. Alright, so if I just talk through the first one question on each as to how to work it out, and then I'll leave you to have a go at doing it yourself. So for A, 18 divided by 2, in other words, how many 2's are there in 18? So you could count in 2's, or if you're good with your times tables, you'll know straight away, it's 9, because 9 times 2 equals 18. So the answer must be 9. 9 times 2 equals 18, and we can work backwards. Alright, we can do the inverse to check the answer. For B, 36 divided by 4, how many 4's are there in 36? Okay, again, you can count in multiples of 4 until you get the answer on your fingers or in your head. Or alternatively, if you're competent at your times tables and you know your 4's really well, you'd be able to say that 9 times 4 equals 36. So the answer must be 9. And then for C, again, exactly the same principle. 81 divided by 9, use the times table knowledge. How many 9's are there in 81? How many 9's? What do I multiply 9 by to get 81? Oh, it's 9. So 9 times 9 equals 81. So the answer is 9. In fact, the answer, I've just realised, complete coincidence, is 9 on all of the questions, question 1 on A, B and C. What I'd like you to do now is have a go yourself. So pause the video. Good luck. Welcome back, everybody. I'm going to go through the answers with you. I'm going to try and do this in my head. Alright, so to save me having to write with the pen, which as you know I'm not particularly good at on here, I'll just share the answers with you. So 18 divided by 2 equals 9, 24 divided by 2 equals 12, 45 divided by 5, the answer would be 9, 36 divided by 3, the answer is 12, 24 divided by 3, the answer there would be 8. I had to work that one out there. 60 divided by 5 is also 12. Okay, then moving on to B, 36 divided by 4 we know is 9, 48 divided by 6 is 8, because 6 times 8 is 48, 28 divided by 4, anyone? Is 7, well done if you got 7, 72 divided by 6 is 12, 49 divided by 7 equals 7, 84 divided by 7 equals 12 as well. Number 1, as we know, the answer is 9. Number 2, how many 9's in 108? It's 12. Question 3, the answer is also 12. Question 4, how many 7's are there in 91? So using your times table knowledge, you know that 12 times 7 is 84, so it'd be one more, so the answer is 13. 121 divided by 11 equals 12 as well. 12 is a popular answer today. And then 56 divided by 7. 7 times 8 is 56, so the answer is 8. Let's have a look at the maths for today. So I'll share the WALT with you again. We are learning to find equivalent fractions. So let's have a look at some questions together. So question 1. What equivalent fractions can you see in these two bar models here? Okay, so we've got one here and one here. So if we were to write a fraction, we know that each single piece of the chocolate bar here is equivalent or is worth 1/9. Whereas below, it's split into 3. So we know that each section is worth 1/3. Okay, but it says what equivalent fractions can you see? So we're looking at where these two lines meet. So where this line here meets and this line here meets, we know that 1/3 would be equivalent. Just get my pen mode up for a minute. So 1/3 here would be equivalent to 3 ninths. Okay, because as you can see, they're the exact same size. Okay, and if we went up to this line, we would know that 2/3 would be equivalent to 6 ninths. Alright, as it will show us now in colour. Alright, so we've got 1/3, 2/3, or 6 ninths, 3/3, 9 ninths, which of course equals 1 whole. So, and then question 2, use the number line to find the equivalent fraction. So it says we've got 3/5 and 5/15. So we've got a number line here. 3/5 equals, so we're trying to work out 3/5 and 15. If you look at this, the scale at the top here is divided, so 0 to 1 has 5 lines. Okay, so this is fifths. At the bottom is 15ths. Okay, so 3/5 is here. So what would that be? What would this be in 15ths? If you count the scales, you'll get your answer. Alright, or I know that there's 3 lots of 5 and 15, so I can multiply this by 3, and that will give me my answer, which of course is 9/15. And then 15/15, what is that? So here's 15/15 here. What is that equal to? Okay, it is equal to 5/5 or 1 whole. Okay, they're both equivalent to 1 whole as well. Let's have a look at a few more. Okay, so we have a shape here split into 2. Okay, so we know that each section here is worth 1/2. The same size shape, or the same size bar of chocolate, but this time we've split it, or we've shared it into 4 equal sections. So each section is worth 1/4. If we're talking about equivalent, we know that 1/2 is equivalent to 2/4, and you can see that by looking at the picture, they're both the same size. Okay, this time, again, the exact same size bar of chocolate. This time we've split it into 6 equal sections. So the equivalent fraction here would be 3/6. Again, you can see they're exactly the same size, they're in line with each other. And then finally, this time I've split my chocolate bar, again the same size chocolate bar, into 8 equal sections. So the equivalent fraction here would be 4/8, alright, which is equivalent to 1/2, 2/4, 3/6, 4/8. They are all equivalent fractions. They are all worth the same value. Okay, like the number sentence there shows. Okay, let's have a look. This is called a fraction wall. So we've got 1 at the top. The next line, so imagine each line is a bar of chocolate, as long as it doesn't make you feel too hungry. If it does, just imagine it as just a bar of nothingness. So we've got 1, and then the second bar is split into 2. So we know that each section is worth 1/2. The third bar split into 3, so each section is worth 1/3, or 1 out of 3. Fourth bar here, 4 sections, so each section is worth 1/4 or 1/4. The next bar split into 5, so 1/5, each section 1/5, and so on. Alright, 1/6, 1/7, all the way down to 12ths. So you'll see each line is the same size. Okay, they're just split into different amounts or different numbers of sections. So let's have a go at trying to find some equivalent fractions using a fraction wall. Alright, so 5/6 is equivalent to what? So the first thing we need to do is find 5/6 on your chart, okay, or your fraction wall. So 5/6, let's look at the 6 column. Here we go, and we're going to count 5. 1, 2, 3, 4, 5. Right, so there is my line here of 5/6. That's the value of 5/6. So what is equivalent to 5/6? What's exactly the same size as 5/6? So I'm going down, if I go up, there's nothing in line at all. But if I go down, there is. Okay? It's this one here, and it's in 12, which isn't a coincidence because we know that 6 is a multiple of 12. Okay, let me just show you this. So there we go, we found our 5/6, and then we go down like I said, and we go straight down, and we see it's directly in line with this section here, which is 10 of our twelfths. So as a fraction, that's 10 twelfths. Alright, there we go. That's highlighted there. So 5/6 is equivalent to 10 twelfths. What I'd like you to do now is have a go yourself. Okay, it's seeing if you can find the equivalent fractions to the three fractions above. So you've got 2/5, 2/3, 6, 6/8. So remember to find the fraction first on the fraction wall, and then have a look along the line to see what it is equivalent to. Pause the video, have a go, good luck. Welcome back everyone, let's see how you did. So looking at 2/5, we found 2/5. We go down and see what it's in line with. Again, not a coincidence, it is in line with tenths because 5 is a multiple of 10. You can fit 2 5s within 10. There you go, so it goes to there, that's 4. If we count the squares, that is 4 squares along. Okay, which therefore means 4 out of 10, which is 4 tenths. So 2/5 is equivalent to 4 tenths. Next question, we've got 2/3. We find 2/3, we go along, we get to 6. We count the number of squares, which is 4 squares. There we go. So the equivalent fraction is 4/6. And then finally for 6/8, you find your 6/8. Oh, sorry, I'm one step ahead. On the previous question as well, sometimes you might find more than one equivalent fraction. If so, write it in, because quite often there is more than one. So also 6/9 was in line as well. So we know that 6/9 is also an equivalent fraction of 2/3. Okay, so is 8/12. Alright, so there might be times where you find more than one equivalent fraction as well. Okay, moving on to 6/8. So we found 6/8, there it is. There's our 6 of our 8 chunks. We go down, we see what is it in line with. We can see it's in line with 12. Again, not a coincidence because they both share similar multiples and factors, okay, of, for instance, 2 and 4. We count the squares and we know we've got 9 there, so 9/12 is an equivalent fraction of 6/8. Also, if we go up, we know that 4 is a multiple of 8, and 3 out of the 4 squares are equal as well, okay, like shown. So 3/4 is also an equivalent fraction. Oh, I think I may have skipped ahead slightly there. Let's get back. Okay, I'm just going to get back onto it. Apologies, I accidentally clicked off of it. So that's today's maths. What I want you to do now is have a go at completing the worksheet yourself. We've gone through most of it. Today is equivalent fractions, but focusing mainly on comparing using a fraction wall. And you've got fraction walls provided within the questions to help you. So have a go at answering the worksheet and please send it across so I can check your work. Good luck everybody. Once you finish, I'd like you to have a go at this challenge. Alright, so if you pause me now, good luck completing your work, and then press play when you finish. Pause now. Welcome back everyone. So once you finish your maths, well done for finishing. Let's have a go at attempting the challenge. We've got A, B and C here. We're looking at equivalent fractions, okay, but we're applying our knowledge to solve problems. So question A, I'm going to read the questions in case you're reading off of a mobile phone and it might be tricky to see. So question A, number 1, Zaina is investigating equivalent fractions. She says that 1/5 is equivalent to 2/8. Is she correct? Explain your answer. So she's coloured in 1/5, representing it as a bar below. Do the same with 2/8. So if you colour your 2 out of your 8 sections in, are they in line? Yes or no? If they're not, we know they're not equivalent, and then you can explain in your own words why. Question 2, which of the shaded fractions below are equivalent? So this time we're trying to match up the equivalent fractions. Okay, so we've got A, which is 1/2, B, which we've got 2/3, C, we've got 4/8, and D, we've got 2/4. The only thing I will say there is a slight clue, is that 3 fractions are equivalent. Okay, so again, good luck with that, A's. B's similar but slightly harder. Again, which of the shaded and written fractions below are equivalent? So you've got some shaded, but this time you've also got some equivalent fractions. Alright, so you're going to have to count the squares and work out which of these are equivalent and write them down. Your second question B is Lola is investigating equivalent fractions based on the shape below. So you've got a shape below and she's cut it into segments or different equal sections. Which equivalent fraction could she have found? It says find 3 possibilities. So looking at this, the first we need to do is we need to work out how many squares there are shaded in, and how many in total. So 1, 2, 3, 4, 5, 6 times 3 is 8. So 18 is going to be a denominator. 3, 6, 9, 12. So 12 18ths. So we're trying to find 3 equivalent fractions of 12 18ths. Okay, good luck with that. And then on C, which the shaded and written fractions are equivalent. Again, same as A and B, just harder. Alright, slightly harder again. Try and match them up, which are equivalent. And again, explain why. So not just the answer, but explain how do you know this. And finally, your last question on C. Reese is investigating equivalent fractions based on 1/4 and 1/4. Which equivalent fractions could he have found? Find 3 possibilities. So you've got a section underneath, so you can split that into a quarter and use that yourself. Okay. What we're basically trying to ask you to do here is, can you find 3 equivalent fractions to 1/4? Good luck, everyone. Thank you. Bye bye.